You know, there's some really cool formulas for finding areas of certain special shapes. And they're cool because they sort of follow from things that we already know. And you gotta love it when something follows from something we already know, because then it's easy. Let me show you an example. Suppose we want to find the area of a parallelogram. Remember, that's where the opposite sides, the two pair of opposite sides, are parallel. Well, it turns out this is actually really easy to compute. If you know the length of the base, let's call it b, and you know the length of the height, and the height is just the perpendicular distance between the roof and the floor, so the top and the bottom. If that's h, then the area is just base times height, b times h. Now, does that sound familiar? Sure does. It sounds like the area of a rectangle, right? Base times height, length times width. Can we see that really happening here? Absolutely. Let me show you how really, in terms of just area thinking, a parallelogram can be viewed as a rectangle. Suppose I just chop off this little triangle piece right here. If I were to slide it over, notice it would fit perfectly in here. In fact, you could actually prove these two triangles are congruent. So in fact, if I were to cut this away and just move that area to here, it would match up perfectly. And then what would I have? I would now have a perfect rectangle that would have base, b, you can see it's still b, and the height is h, so it's base times height. There's the formula. No problem at all. So let's take a look at some examples where we can see this in action. All right, so we're given a lot of information here, and I want to see if I can figure out what the area of this parallelogram is. So let's see. The base can be seen to be 12 centimeters, so that's straightforward. And the height, the height actually I don't know, so that's not good. I know the length of this sort of side, which is not the height, that's 5. And I'm told that this overhang is actually hanging over 4 units. So if you notice really closely, I've got a little teeny right triangle right here. You see it? It's 4 for one leg, h for the other leg, and 5 for the hypotenuse. I can actually use Pythagorean theorem to figure out what the height is. So you could say 4 squared plus h squared equals 5 squared and solve. Or you might be attuned to the fact this is a very special right triangle. It's a 3 blank 5 right triangle, where the blank is 3. Oops, again, wait. 4, 3, 5. 3, 4, 5 right triangle. So if we put a 3 in here for the height, and you can check that. 4 squared is 16, 3 squared is 9. You add them up, you get 25, which is 5 squared. So now I know the height, and so therefore, what's the area of this? It's going to be base times height, 12 times 3, which is 36 centimeters squared. Cool. All right, let's try another one. All right, so let's just take a look at a regular old-fashioned rectangle. The base is given to be 7 centimeters. The height we don't know. We're just calling it h for now. And the question is, well, what's the height if we get one extra piece of information? The area is this algebraic expression, 14x plus 7x cubed. Well, we know that area equals base times height. And that's going to equal 14x plus 7x cubed, because that is the area after all. Well, if I want to solve this for the height, I just divide everything through by 7. And so I see the height equals. Now notice on this side here, there's a common factor of 7 that I can factor out. Oops, that should be a 2. So now when I divide both sides by 7, I see I can actually simplify this a little teeny bit. And I see that the height is equal to 2x plus x cubed. And my units here, of course, are centimeters. It's a length. So it sounds kind of silly. You're like, well, gee whiz, that's a funny value for the height. But remember that all we know about the area is that it's a funny expression in terms of x's, and so therefore the height should probably be some other kind of funny expression in terms of x's as well. So no huge surprise, I'd say. No huge surprise, but still maybe a little surprising, which is sort of good. I love surprises, especially on my birthday. All right, let's see. Here I've got a regular rectangle again. I see that it's 17 inches in length and the height is h. And I'm told that the area is 34x squared. Okay, I don't know what x is, but I'm asked to find the perimeter. So the only way we can actually find the perimeter is in terms of x, since we have no idea what x is. Well, we know what the perimeter is. The perimeter, we just literally add up the lengths of all the sides. So we have an h here and an h here, that's 2h, plus, and we have a 17 here and a 17 here, that's 2 times 17, which is 34. So there's the perimeter, but I'd love to have that just in terms of x's. So what do I do? Well, I know the area is 17 times h, base times height. All right, and I know that's supposed to equal 34x squared. So what do? Well, I solve for h. Divide both sides by 17. And I see h equals, well, let's see, 34 divided by 17 is just 2x squared. So really, h is just 2x squared. If I insert that in for h here in the perimeter, I get the answer that we were searching for. It's going to be 2 times h. That's going to be 2 times 2, which is 4x squared plus 34. So 4x squared plus 34, and perimeter, the units is its length, so it's inches. And there you have it. So even when you have sort of complicated unknowns inside of various quantities in terms of areas, we can find perimeters and other lengths without a problem. We just got to think through it. And in terms of the parallelogram, I think it's clear that it really is just a displaced rectangle that's trying to find its way in the world.